Let us solve the first one and see what is the idea and where is the transformation. This is the first problem. Now, by looking at the problem, it seems that it is not in a standard form. So we have to do some kind of transformation. So what is the idea here? First, I will take the reciprocal of this equation. So the reciprocal, we will have 1 over an is equal to an minus 1 plus 2 over an minus 1. So it looks like here you are dividing 1 over n, and then you are dividing 1 over this value, so it will turn over, and this is the equation that we are going to have. Next, this equation, since we have a plus in the numerator, so we will have an minus 1 over an minus 1 plus 2 over an minus 1. So we have 1 over n is equal to 1 plus 2 over an minus 1. So if you look at the terms of a, both an and an minus 1 are part of a rational number in the denominator. So we have 1 over n. And if you look at this one, if you take just 2 outside, this is also like 1 over an minus 1. So how about if we do the following transformation? We will say, let Bn, so I will change the name of the recurrence relation into B, let it equal to 1 over an. In this case, what will be Bn minus 1? Bn minus 1 will be 1 over an minus 1. So 1 over n in here is Bn, and 1 over n minus 1 in here is Bn minus 1. If you do the substitution, you will have Bn is equal to 1 plus 2 Bn minus 1. Because here we have 2 multiplied by 1 over an minus 1. By rearranging this recurrence relation, we will have Bn minus 2 Bn minus 1 is equal to 1. So we have transformed this recurrence relation into another recurrence relation, but this is this transformed one. So we will solve it. This is non-homogeneous recurrence relation. We will solve it like what we have done before. We need to find the characteristic polynomial. So the characteristic polynomial will be equal to the characteristic polynomial is, we will have x minus 2 multiplied by x minus 1 for the non-homogeneous part for the function. So we have two roots, r1 is 2 and r1 is 1. So the general solution for b, so bn, maybe I should write the general solution. Then the general solution is Bn is equal to C1 times 2 to the power k plus a, because the other root belongs to particular solution. Now to find C1, since Bn is equal to 1 over a1, so in this case b1 will be equal to 1, or here n, a1, and b1 is equal to 1 over 1, because a1 is 1, so we have 1. Because the recurrence relation is bn, not an, because it was transformed. So we found the initial value. So finding C1, and n is here, n is equal to 1. So you substitute into this equation. So what you will get? You will get B1 is equal to 2 C1 minus 1, and B1 is 1. So from this equation we have 2 C1 is equal to 2, and C1 will be equal to 1. So when we substitute for C1 into this equation, we will have Bn find a space, okay. So we will have Bn is equal 2 to the power n minus 1. But in the beginning, we did the transformation since Bn is equal to 1 over An. So what will be the value of An from this equation? The value of An will be 1 over Bn. And the solution for Bn is already found. So we will say that An is equal to 1 over 2 raised to power n minus 1. And this is the final solution.